Good day, everyone. I am Charles Ian Echavez,
And I'm Argerheyco Tubat.
and this is our research proposal. Our research is about piezoelectric tiles. So, what is piezoelectric tiles? It is a type of tile that uses piezoelectric materials like quartz that generate electric charge when pressure is applied. Although piezoelectric effect was discovered on March 1888 by Jacques and Perry Curie, it was on 2008 when Lawrence Kemba Cook introduced piezoelectric tiles to the market. After that, different brands of piezoelectric tiles emerged. So the title of our research proposal is Installing Piezoelectric Tiles to Light Up Specified Street Lamps from Rizal Avenue, corner Quezon Avenue to Rizal Avenue, corner F. Lacaya Street, Dipolog City.
We are living in a convenient world where we can see artificial light inside our households, produce air cooling and heating system, transport from different places through cars and access information through an artificially built devices. In order for these devices and systems to function, it is customary to apply electrical power. The Philippines is an emerging country. Therefore, its population is increasing. Thus, the demand for electricity is also increasing. The Philippines is highly dependent on coal as source for electricity generation. Coal power plants generated 46.8 megawatt-hour in 2017. Coal-fired plants produce electricity by burning coal to produce steam. The steam produced under tremendous pressure flows into turbine which spins a generator to create electricity. However, coal combustion emits carbon dioxide, sulfur dioxide, and other gases in the atmosphere which is responsible for trapping heat and can cause greenhouse effect, acid rain, and smog. Harvesting kinetic energies is a sustainable method for generating electricity without depleting natural resources. There are two main methods to convert kinetic energy into electrical energy: the piezoelectric generator and electromagnetic generator. In this study, the researcher used piezoelectric generator to harvest energy from mechanical loading generated in the ground in the shape of compressive forces and converts it into electrical energy. Piezoelectric tile does not emit inorganic and toxic gases that can pollute the atmosphere. In addition, it does not accumulate large area of land for building the system unlike power plants. However, these tiles can only produce a small amount of power per footstep.
Statement of the problem. The sources of electricity are vast and are waiting to be explored. One of the sources of electricity is the piezoelectric tiles where it converts kinetic energy into off-grid electricity. The energy consumption is escalating as population rises exponentially. It is important to reduce the consumption of energy in order for the country's sustainability. Hence, it is necessary to incorporate another source of renewable electricity, which is the piezoelectric tiles. In particular, the following research questions will be addressed. 1. What is the average power generated per footstep on the piezoelectric tiles? 2. What is the estimated lifespan of the piezoelectric tile in years? 3. What would be the estimated cost of installation of piezoelectric tile and the return of investment in years for each brand? And 4. What brand of piezoelectric tiles is best to use?
Significance of the study. This study aims to produce an alternative electrical power source derived from mechanical stress using piezoelectric generator. It is beneficial to the following. The community. This study is beneficial to the community, particularly in Dipolog City, Rizal Avenue. The power generated of the piezoelectric tile illuminates a particular portion of the previously mentioned avenue. Street lighting is important for public safety. It improves the safety of drivers, riders, and pedestrians at night time. This study is also beneficial to the environment since piezoelectric tile are considered as renewable energy source. It helped reduce the emission of carbon dioxide and other global warming emissions. The researchers. Researchers working on topics connected to piezoelectric material will benefit from this research. The data presented here, as well as studies' pertinent findings, can be utilized as a starting point of their research.
Scope and limitation of the study. The energy generated of the piezoelectric tile will depend on the number of steps per tile and the weight of the person stepping the tile. This study is primarily focused on the installation of piezoelectric tile to light up specific street lamps in Rizal Avenue with the use of piezoelectricity, which converts mechanical stress into electrical energy. The study is limited to the use of piezoelectric tile as the alternative source of electricity for the street lamps, and it will only circle in Dipolog City, particularly in Rizal Avenue, year 2021.
Theoretical framework of this study. This study is heavily anchored on the theory of piezoelectric effect, where certain materials, such as crystal and some ceramic, have the ability to generate an electric charge in response to applied mechanical stress. Piezoelectricity is commonly found in today's electronic devices, from quartz watches to speakers and microphones. The cause of this phenomenon was found lie on its atomic structure. An illustration of direct piezoelectric effect is shown in Figure 2. The direct piezoelectric effect happens as a result of direct stress to a material. It occurs when pressure, typically using two metal plates, is applied to a piece of piezoelectric material such as crystal or ceramic. Metal plates clamp the piezoelectric material and collect the charge as it is generated. As mechanical pressure is placed on the piezoelectric material, its positive and negative charge shift, which creates an external electric field. Figure 3 shows the illustration of inverse polarization effect. An electric current compels the atom in the material to vibrate back and forth, and that process is called the inverse piezoelectric effect. The piezoelectric effect is reversed by applying an electrical charge to shrink the crystal, then converts electrical energy into mechanical energy.
Conceptual framework of the study. This study is anchored on the concept that the waste energy from humans can be converted to electricity using piezoelectric material. A significant amount of electricity from the piezoelectric tiles will be used, with the electric utility acting as a backup if the piezoelectric tiles are unable to store enough electricity to power the street lamps at night. The figure 4 explains the relationship between variables. The first box of the schema contains the independent variable of the study, which is the pressure applied to the piezoelectric tiles. An arrow from the first box is pointing to the second box, which contains the dependent variable, which is the production of electricity. The up arrow signifies the production of electricity is influenced by the number of steps on the piezoelectric tiles. Research methodology. A piezoelectric tile will be placed near each street lamp's post from Rizal Avenue, corner Quezon Avenue, to Rizal Avenue, corner Father Lacaya Street. The flowchart, shown in Figure 6, represents the working process of the entire proposed system. The mechanical input energy source is subsequently converted into electrical power output via piezoelectric generator. Then, using the rectifier, this power is rectified into a DC power supply. The rectified output from the piezoelectric transducer is then doubled for transmission via DC boost converter system. The generated energy is then stored in the battery for subsequent use.
Data gathering procedure. The first step that we need to do is gather the number of people that walks from Rizal Avenue, corner Quezon Avenue, to Rizal Avenue, corner Father Lacaya Street. And also, we need to gather the monthly electric consumption of the two street lamps that is retrieved from Argerheyco. The next step that we need to do is calculate the average footstep per day per tile from Rizal Avenue, corner Quezon Avenue, to Rizal Avenue, corner Father Lacaya Street. And also, we need to calculate the daily electric consumption of the two street lamps. To perform an analysis to the tile, we must first determine how much electricity they can generate over the lifetime. According to Campbell Cook, 250,000 footsteps provided enough electricity to charge 10,000 cell phones. A fully charged cell phone requires approximately 3.68 watt per hour for 2 hours. The energy generated by each footstep is computed as follows using this data and the information provided by Kimball Cook. 10,000 times 2 times 3.68 watt-hour is equal to 73.6 kilowatt-hour. Therefore, the energy per footstep is equal to 73.6 kilowatt-hour divided by 250,000 footstep, which is equal to 0.294 kilowatt-hour per footstep on average. Assuming that there are 30 days in a month, the daily energy consumption of the street lamp will be daily energy consumption is equal to monthly energy consumption divided by 30 days. Based on the assumption, the amount of passerby in the said street for a year will be average number of footsteps per year is equal to average footstep per day times 240 days per year.
The brands that we will be comparing are sound power with a lifespan of 20 million footsteps, way energy with a lifespan of 20 million footsteps, and sustainable energy floor or SEF with a lifespan of 15 million footsteps. The lifespan in years is estimated using this formula. Lifespan in years is equal to lifespan in footsteps divided by average number of footsteps per year. For the estimated cost of the project, the following formula will be used. Total cost of installation is equal to initial cost plus shipping fee plus mounting cost. To solve for the initial cost, we have the formula. Initial cost is equal to unit and its equipment price times number of tiles. For the return of investment or ROI in years, we have the formula ROI is equal to the total cost of installation divided by the cost of energy produced. From the result of ROI, we can determine which brand of piezoelectric tiles is best to use. So that's the end of our presentation. We sincerely appreciate your attention and time in watching this video. If you enjoyed or learned anything in this video, please leave a like, comment, and don't forget to subscribe to the channel.